Here's our last exponential equation word problem, and in this problem we're going to do quite a bit. We're going to use a lot of the skills you just learned and a lot of the solving techniques. So we're going to put it all together. Solar power cells have become more affordable in recent years. In 2009, the cost per watt of solar power cells was $4.85. In 2013, the estimated cost will be $2.92 per watt. Assuming the cost follows an exponential decay, we're going to do three different things with this problem. They're all related. So let's get started by grabbing our note card with this function on it, because we're going to use this exponential decay function. In this case it's decay because it looks like the cost is decreasing. Let's analyze a couple of things. 2009, the cost was $4.85, so it started out at that. 2013, the cost went down. It's now only $2.92 per watt of solar power. So we have a time difference here of 4 years, and we have an amount that starts here and results here. So we can start making our list of what we have. We have P equals an initial amount of $4.85. Always make this list as you're solving these equations. We have A of t, the resulting amount after a certain number of years, of a lesser amount, $2.92. We have t, the time that elapsed between those amounts was 4 years. And the thing we're missing is k, that rate that the price decreased. And that's exactly what we're going to do in letter A. We're going to find that rate. So let's do this. Let's take our function and fill in what we know and find the missing k. So A of t is $2.92. The smaller amount is here because this decreased. P is the $4.85. E is always in the function. We have t, the years, and what we don't know is k. I'm going to put k behind t in this case, just because we like to have the numeral in front of the variable. Alright, we have to solve for k. We can't do that until we get the exponential part of the function alone. So to do so, we have to get rid of the $4.85. It's multiplied by e to the 4k, so we undo by dividing. What we do to one side of an equation, we do to both sides. So I grab my trusty calculator. $2.92 divided by $4.85, and I get about 0.602. 0.602 is equal to e to the 4k. Bring down the rest. Alright, now I have to undo e, and just like in our last problem, what undoes e? ln undoes e. So I take the ln of both sides. Oops, I need a decimal point there. Okay, I should have a 0 in front of that decimal point, but I kind of squeegeed my room there. Okay, on this side, ln eats e. 4k comes crashing to the ground, no longer an exponent. And on this side, I take the ln of 0.602. So ln key, 0.602. Close my parentheses. And I get about negative 0.507. Negative 0.507. Now, I'm still going to work on getting k alone here by dividing both sides by the 4 that's multiplied by k. The 4's are gone, and I get k equals, and I've got that last answer in my calculator, so I'm going to just take and divide that by 4. And I get about negative 0.127. Negative 0.127. I'll write that bigger so you can see it. And if you were asked to make that a percent, that's negative 12.5%. We're going to use this number though as we continue the problem, but just to give you an idea of what's going on, the price is decreasing by about 12 7/10% per year. That's a pretty good decrease. Okay, so we've accomplished letter A. We found the rate of decrease, this number I circled, the k. And in letter B, we're going to use that now in our function to find the predicted costs for 2015 and 2018. That might be handy to know if you're in business and you want to project company profits. So let's start letter B. I'm going to work with the same formula now, but I know A of t. A of t is $2.92. Oh, no, I don't know A of t. A of t is the result, and that's what we're finding in letter B. We're finding the resulting cost after a certain number of years. So I actually need to start like this. Don't know A of t. But I do still know that the initial cost was $4.85. I have my E, and now I have both K and T. I have K from solving, and that's negative 0.127. Do not forget that negative sign, it's huge. And then times, now my years, 2015 from 2009 to 2015, isn't that 6 years? That's 6 years, 2015 minus 9. So I'm going to be putting in times 6 for T. Remember your formula. T stands for time. And then it's just a matter of cranking this out in my calculator. So let's do it. 4.85 times, go get E. There it is. And what I'm putting in the parentheses is negative. Don't forget the negative sign. 0.127 times 6 years. And I get a result of about $2.26 per watt. So A of 6 years was about $2.26 per watt for the solar power cell. And likewise, if I want to find A of 2018, I'm going to put in the years. So 2018 minus 2009. Now we're looking for the cost after 9 years. So I'm going to be doing A of 9. Same idea, 485 times E to the negative 0.127, but this time times 9 years. Now I still have this equation in my calculator, and if you're lucky enough to have a calculator like me, you can do just what I'm doing. Go back and type over the 6 and put in a 9. If not, you'll have to enter this as you see it here and redo it. And now I get about $1.55, 1.5 rounded to a 5. So A of 9 was about $1.55. In the next video, we'll finish this up with letter C, finding the decay rate, at the same decay rate, when will the cost only be $1? So tune back in for that one.